NetSparker, the developers of a comprehensive automated web security platform that includes web vulnerability scanning, assessment, and management. NetSparker's desktop and cloud-based security solutions employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities and provides a proof of concept. For more information, visit them on the web at securityweekly.com/NetSparker. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/securityweekly for an unlimited data trial and gain uncompromising visibility today. Welcome back, everyone, to Paul's Security Weekly. Join the Security Weekly mailing list for webcast virtual training announcements. Receive your invite to our Discord server. We are working on an update to securityweekly.com/subscribe. Pretty soon you'll be able to subscribe to the mailing list, join our Discord server, and subscribe to all of the shows on our network in one neat little package on our website. So make sure you check securityweekly.com/subscribe for all things Security Weekly. Join the mailing list, find out about upcoming webcast virtual training and other such events that we've got planned. Let's see. Siddharth Bhatia is a PhD student at the National University of Singapore. Siddharth's research is supported by the President's Graduate Fellowship, and he's been recognized as a young researcher in the ACM Heidelberg Laureate Forum. Siddharth has done breakthrough work in streaming anomaly detection. His research, MIDAS, finds anomalies or malicious entities in real time. Siddharth, welcome to the show.
Thanks, Paul. Thanks for inviting.
Yes, nice to have you on, Siddharth. How did you get your start in information security, and kind of what interested you in doing research in the area of security?
So when I joined my PhD, so I wanted to, after my PhD, I want to go into academia. So during my PhD, I was always interested in data science, machine learning, and somewhat related in graphs and these kind of things. So I found anomaly detection was an interesting problem, and I'm doing my PhD, so my advisor, he was also interested in a similar topic. So within anomaly detection, currently in cybersecurity space and other things, there's a need for kind of a streaming or a real-time kind of anomaly detection. So where we want all the malicious entities to be recognized as soon as possible so that the harm is minimized. In intrusions, DDoS attacks, even the recent Twitter kind of attack. So if we could recognize or detect it as soon as possible, so the harm is minimized and so many millions of dollars wouldn't have got lost. So that was my motivation, and I've been working on streaming anomaly detection in my time throughout. So yeah.
That's awesome. So where do you collect the data from to do this analysis, right? Is it network? Is it net flow? Is it events? Is it a culmination of it? What data are you ingesting to start this analysis?
So it's most of it is net flow data only. So it's not restricted to net flow data. I'm working on net flow data, and I showed experiments with net flow data, and it's being deployed in real world settings as well to just see how the data, net flow data, how it is working there. But I was primarily working with publicly available data sets, because as a researcher, I cannot use someone else's copyrighted data. So there is a Canadian agency, CIC, Cybersecurity Institute. So we use their publicly provided data sets and some data sets by DARPA. So I showed experiments on those, but definitely my research is not restricted to net flow or intrusion detection data sets. So any a record kind of data, or if you have a graph kind of setting where you have a source port and a destination port. So those kind of data sets we can experiment with those.
Well, what were some of your strategies for finding anomalies? What was the basics of your theory?
So in recent times, earlier, if we talked around 10, 20 years back, so most of our settings and most of our communications were actually static, and they were fixed. So you knew that, okay, this is your entire communication network or something like that. But recently, all time evolving or dynamic communications, and basically if you consider two people or two nodes, two machines communicating with each other. So that kind of graph is evolving with time. So one of the primary requirement is that we have to have an algorithm which works with dynamic nature. So you can have new nodes which you don't know about. You can have new edges. So you take any social network or any other kind of like communication network. So you do not know which nodes will be interacting. So other thing which is important is that we cannot have an algorithm or some kind of detection system which will grow with the number of nodes or with your stream length. So you want it to be constant, like in memory, and you want it to be constant in time. So you want it to be, if possible, real time, or even if it's not real time, something of the order like near real time, maybe like it may take like few seconds, something like that, so that it is detected as soon as possible. So the other thing is that recently there are a lot of coordinated kind of attacks. So it's not usually one person is kind of sending you a lot of edges. So it's usually like multiple entities are coming in together and they send a distributed denial of service attack, something like that. So we want to find sudden surges in the number of requests or your number of communications. And based on that methodology, we wanted, we came up with this microcluster detector. So it's called MIDAS, and it can find like coordinated entities coming in together and sending a similar suspicious group of edges within a very short span of time. So that is the basic methodology to find out like what are the intrusions or malicious entities or the anomalous communications. And so it's just up to detection. So prevention and other things is not there currently, but yeah.
So Siddharth, does this start learning what is normal and then flagging what is abnormal? Or is this a system, almost sounds like it's doing it in real time. In other words, analyzing streams of data as it's going, coming through the system and determining if something anomalous is happening. I think previous systems have very much relied on, we sit on your network for a while, we look at all the net flow, we determine what's normal, and then we look at anomalies. It sounds like what you have is different.
Correct. We're also analyzing in a streaming fashion. So it's always better if you have like an increasing kind of like as much stream as it is possible, but it'll start detecting from the very beginning. So we have an expected behavior for each user, and the beauty lies in the way we are hashing it to a compressed space. So we are hashing like similar users in a similar bucket, and like that way kind of I won't go in the details of the data structure, but like once you hash it to a compressed space, you can kind of map your user behavior and you can find your expected behavior, and based on that you can see, okay, this was anomalous. For example, if you had say 10 communications happening between two nodes, so suddenly you see that, okay, 1,000 communications happened in the last 2-3 minutes, so what did happen? So something like that. At the same time, like if you see, okay, just the same tweet is kind of sent multiple times, so what really happened down there? So is it like some kind of a hack or something like that? So right now it's kind of a like on the order of like if it's more than the expected behavior, and we model an expected behavior over the entire stream.
It sounds like you can get the expected behavior very quickly, right? And not have to listen for days or weeks, right?
Yeah. So like there are a lot of deep learning based approaches, and there are a lot of other security related approaches which will also find your expected behavior, but they do take a lot of time. So in our case, we are using a streaming data structure. So like I said, in streaming algorithms, or when you're working over a stream, so you want like some form of a streaming data structure which does not need to store everything. So you cannot actually store everything. And another nice thing is that when you're running it, like when you are learning the rate or your expected behavior over days, so your learned behavior is actually old now, right? So your current behavior may be actually different than what your previous behavior was. So in a streaming fashion, you're learning there and then. You do not have the time or the luxury to kind of learn your past. So you're learning there and then. And once you see the data, you don't really need to see it again. And then you can detect it there and then. You have a threshold. That threshold can be application or company dependent. Like, okay, more than this, we are considering it as an anomaly, and what we do with that anomaly or that intrusion. So whether we detect it, like we prevent it, we block it, we give it a warning, that all is separate. But yeah, so the expected behavior is learned over a stream as soon as possible, and that is done using a streaming data structure and like a chi-square goodness of fit test. So combining those in an algorithmic way, so we do that.
Is the learning that you get on the system, is that cumulative so I can learn from what you already know, or do I have to start all over again if I implement this? I mean, is there like a repository where I say, okay, I'm going to go ahead and pull down all the knowledge so far and add that to mine, or do I just have to start clean every time?
So currently we have it clean for every time, but definitely that's a very interesting extension where we can take someone else's expected behavior and like have that behavior also learned and like maybe use that at the initial time. So after some time, there'll definitely be personalization and your expected behavior has to be different from someone else. But there can be some kind of a global expected behavior which we can use also to kind of improve it further. And for the initial phase, we see that this is your expected behavior.
But I love the approach because it's looking at almost in near real time, Siddharth, as you were saying, like what's behaving differently, because things change all the time. And I remember doing this monitoring university network, right?
Yeah.
Like students would do new stuff all the time. And that was essentially normal, right? But like, how do you pluck the anomalies out of that normal that's changing all the time? Historical data was almost meaningless to me because it was constantly changing, right?
Definitely. And like even for example, if you say like you have different kind of users, so like if you take, so not just going into the communication example too much, like if you see, for example, your Twitter network or something like that. So Donald Trump will be sending in a lot of tweets, right? Like I, as a normal user, will be tweeting once a week. So what is the different expected behavior? You cannot really model one kind of behavior for every user. So it'll be slightly different there. And you also, at the same time, you also want your like the a guarantee on the false positives which your algorithm or your system actually detects. So you do not want as many false positives. Okay, I have the luxury to give you as much false positives as like it is as my algorithm is giving. So we have a tolerance on the error also. Okay, if you want only 1% error, so we can have a data structure customized to that. If you want say 0.1% error, you cannot tolerate more than that. So we have a guarantee on the false positives also, which is a theoretical guarantee based on the algorithm. So that is quite nice.
So the user can kind of tune those thresholds.
Yeah.
Yeah. So the user can basically say that, okay, with 99% probability, I cannot afford more than 0.1% error, something like that. So we'll tune in the parameters based on that, and it'll require slightly more space, slightly more time. But overall, so it's like the guarantee will work. And say we experimented on my normal like Mac, so around 4.5 million DARPA records within less than 1 second. So that was what was the order. So yeah, a few milliseconds here and there won't affect too much.
So since it starts clean though every time, what's the like cycle time up to where the deep learning actually is trained, and I can start sort of counting on these things? So with my streaming environment, so how many conversations of some length of time do I have to have before the deep learning is really saying I know what to do?
So just to like clarify, so there are two things. So machine learning won't require any training. Deep learning requires training. So in this particular problem setting, we are actually not using deep learning. We're using machine learning.
Oh, okay. I'm sorry. I misunderstood that. Excuse me.
Yeah. So it won't require like a training or your initial set of records. So it'll start from the very beginning. Obviously, your first or second record, it won't consider it as an anomalous.
Okay.
But like within just a few records, it starts working and it shows promising results. I'm also trying to extend it if I can use some of the innovations in deep learning and maybe have a streaming scenario, because that is one very interesting thing which you pointed out, that current deep learning approaches, they require some form of initial training or some form of an initial data set to train with, and then only you can work and it can like give good results. So how can we kind of have a streaming deep learning based solution, and if we can hybridize those?
Well, that I thought
That's
earlier.
really that's really interesting though.
Yeah,
when
no,
he
I
said
thought
combined.
earlier he said it was using deep learning, and that's why I was asking the question about, or do you have like a global store of deep learning knowledge I can draw on? But if it's machine learning, yeah, that makes sense. So that's a different approach. But I like the deep learning idea. So I think that, because I do think that streaming is something that you can sort of, quantify in a finite way as far as behaviors. So it seems like that might be a good place to go with that as well. I mean, the machine learning works for that well as well.
But Siddharth, and Doug, it sounds like detecting a denial of service or distributed denial of service attack, this would be a very, very fast way to detect that, right?
Yeah. So like when you have like constant time, and if you have at the same time if you have constant memory, so like it's kind of works really fast, and also we're doing some really simple kind of transformation. So and some like so getting it down to, so we use sketches. So sketches bring it down to a compressed space, and it denoises some of the data as well. So using those approaches, it works really fast, and so it's order like around 3 orders of magnitude faster than the earlier baseline. So that was around 2 years old. So that was also working in a streaming fashion. So streaming does not correlate, like it does not mean that it's real time. So streaming means that you just have a streaming data. So real time also has like different connotations for different people. It can be real time, maybe say minutes, maybe hours as well. But yeah, within real time also it's kind of faster than the previous approaches. So I'm trying to extend it further and like say maybe use correlations of the net flow data, like you pointed out. So if you use net flow data in the previous segment, so like if you use net flow data, so you have different kind of packet size, average flow duration, and if we can somehow find the correlation between those features and like improve the anomaly detection further, so that is definitely an interesting extension as well.
Siddharth, is part of your kind of anomaly detection based on outliers, right? Is it like, do you look at all the streams that are coming through and kind of pick out the outliers, frequently occurring, most frequently occurring, least frequently occurring, data sizes, things like that? But doing that in a stream fashion, I think is really interesting.
Yeah, so when we're basically working, so we're just analyzing one stream, and within that stream, so it can be run parallelly across multiple streams. So I'm also trying to do that because of the speed up. So it'll definitely be interesting to do it in parallel and in a distributed fashion. But currently, like the version which is available online, so that is running on one particular stream, and within that stream, we are seeing the unexpected behavior and analyzing that and trying to detect that or like give it as an outlier.
In your testing, are there certain anomalies or attacks that you are very confident in this technology detecting?
So like there are some like, so I'm not too familiar with all the attacks which it detects because I just use like publicly available data sets, but Neptune and like, so there was Smurf attacks. So these were the different names of the attacks, and also at the same time, so it'll recognize insider threats, it'll recognize your denial of service attacks, it'll recognize intrusions, it'll recognize if you want to have like if you have fake if you have unauthorized access for a particular file, so it'll recognize everything wherever there is a sudden surge in the data or in the requests. So I didn't see which all type of attacks it'll recognize, but it definitely won't recognize something like if you're impersonating as a user, but if you're impersonating as someone and if you do some unexpected behavior, that it'll recognize.
And that's really where it's at today, right? Because most attackers don't do the kind of blatantly obvious, this is anomalous. They're trying to impersonate user behavior as closely as possible. But inevitably, there's some variations where technology like this really can help us.
Definitely, like that is one of the, so even I was surprised, like there are so many kind of DDoS attacks still happening, and this can kind of like, this should be done as soon as possible, because this is just like, even by normal eyes, we can see that there's not like an expected behavior, right? Like something happening on Twitter, or like there was a GitHub DDoS attack which happened. So it can be recognized very simply, and it should be done very fast. So this is, if a human is able to see that, like, okay, this is not an expected behavior. So like when you have statistics and when you have like learning, so that should definitely be done faster.
So do I just set this up like on a server on my network side, and then when my streams are coming in, I redirect them to your tool MIDAS, or is NetFlow data just being redirected there? How do you collect this information?
So like I am not a developer, so I just kind of build the basic version where you have all the data, and you just kind of run the algorithm based on that.
Okay.
But there are other developers who've like contributed to the like to different implementations. Like I had written a like original C++ implementation. People have implemented it in Python, Java, Julia. Some are running it as a streaming service on a web app. So there are different other implementations. I was like I designed the original algorithm with like my collaborators, and we just like had a C++ implementation, but like definitely it should be used as a streaming service where you have a stream coming in and you can use it. And there are other implementations, those are available on the GitHub repository, but I was primarily behind the C++ implementation and the algorithm design.
Okay.
It sounds like, Siddharth, you had like the reference implementation, then other
Yeah.
people applied that to
Correct.
their various technology.
Yeah.
Yeah. That's really cool.
Yeah.
What has the response been? Like, what was the most kind of surprising thing when people started taking your methodology and applying it to those different languages and applications?
So people were also interested in the speed which MIDAS was giving. So they were everyone was fascinated with okay, it's running quite fast and it's giving good results with theoretical guarantees. So a combination of those is definitely interesting, and people started implementing it. At the same time, the implementation was quite simple, so it was easy to port it to different languages. And so then there on like some cybersecurity companies, they contacted us to if they can fine tune it on their system, and if they can run it, and how do they customize it for their data. And it may not be like that every company wants it on their NetFlow data, or if they wanted something like on their communication network or something. So basically MIDAS can run in any graph setting. So people found out different use case scenarios. Okay, there's a financial fraud in our company, can this run on it, because it's giving
Right.
fast results. So they want like a credit card fraudulent transaction to be stopped as soon as possible, and they want the harm to be minimized. So it can run in financial fraud settings, it can run in fake ratings where Amazon, so I'm currently an intern at Amazon, so AWS. So Amazon has this requirement where you have fake reviews, or like people just posting fake reviews on their
Yeah.
apps in Google or iPhone and in the App Store. So they want those to be detected as soon as possible. So it can run in those scenarios as well. Wherever there's a time evolving graph, and the graph is like dynamic in nature, you're receiving new edges, you're receiving new nodes between sources and destinations. So it was quite interesting to kind of work and see what all different scenarios people are showing. So like even I got many like further ideas how to continue and extend this research in like different settings. So I'm working on deep learning, like introducing deep learning in this setting and how it can improve the results further. And we're also seeing if an analyst can give kind of some feedback or semi-supervised learning. So semi-supervised learning will be if you have like some analyst saying, okay, MIDAS detected this as an anomaly, but this wasn't. I knew this person. So this is just an expected behavior. Something wrong happened there. So don't trust it as an anomaly. Just improve your algorithm further. So if an analyst can give some feedback, so these all ideas came like via the community discussion. So it's definitely very helpful.
And is there an application that Amazon is using it to detect like fake reviews and things like that?
So so even I am not aware what all they can they'll be using, and they signed like they got me to sign an NDA contract that I cannot release any information which is
Well, of course,
publicly,
yeah, no,
which is
and Google
Amazon.
and all the companies do the same thing with the,
Yeah.
basically their version of fraud detection. They don't want to release how they do it, obviously, because then people would have a leg up to reverse engineer it, right? Totally understood. Yeah.
So the other interesting thing with MIDAS is that, okay, if you know that people are trying to use MIDAS to protect their system, so what you can do is even if you go from if you try to become an adversary and break MIDAS, something like that. So what you'll do is you will actually come back to your expected behavior. So that is the only way how you can actually not get detected by MIDAS. So it's not really difficult for MIDAS to. So for example, if I am an anomaly or I am a malicious entity, and I want to get I don't want to get detected by MIDAS. So what I'll do is I'll go back to an original expected behavior. I'll send in like a specific number of requests only, and if that is the behavior, so you actually cannot do anything anomalous, right? Like so, usually all these systems, your fake reviews and other things, they are successful only when you have a sudden surge in the requests. So
Right.
if you break that, so if you don't have a sudden surge in the request, then your behavior itself becomes normal, and you will no longer be detected by MIDAS, but at the same time you will no longer be able to act maliciously. So that's kind of a two-way game. Yeah.
Yeah, it sounds like rate limiting, or at least limiting or randomizing the requests, could defeat some of the detection, right? I mean, we've employed similar techniques, right, to be able to step around and do things like scraping and other things, right?
Correct. Yeah. So it'll do exactly that, and after once you detect, so it cannot if you use it with other approaches, you will be able to detect other attacks as well, and that'll be kind of a good enough complete solution. And yeah, that is just the simple idea which we were trying out with MIDAS, and it worked quite wonderfully.
Jeff?
Yeah, hopefully this won't be a stumper of a question, I'm thinking ahead to our news segment because I have my single link is to a security bulletin that was put out by Visa, the credit card company, about some variants of malware that they've detected recently. And what struck my interest in the security notice was their method of exfiltrating data is using DNS tunneling. So not meaning to trip you up, but I'm just curious, does MIDAS does it, or how does it, or can it detect anomalous activity in what's traditionally considered sort of normal traffic, something like DNS traffic?
Good use case.
DNS traffic and other traffic will be like whenever you have a source and a destination. So you can have like kind of a multi-graph. You'll have a source IP address, you'll have a destination IP address, and you'll have communications happening between those, and it'll be evolving with time. So for example, you have two communications in the or you have two packets in the first flow, you have multiple other packets in the other flows. So in those scenarios, you just like model it as a graph, and once you have a graph, so then MIDAS will work like naturally like in a graph setting. So definitely like we are trying to extend it to non-graph settings also, so that like that research paper is currently under review, and we've implemented that as well. But right now it works with whenever you can model kind of a graph, your communications over the network, you can model it as a graph, so there it can work. And there's also an interesting exploration which can be done. So because all these kind of communications are happening over the network, right? So instead of having that data and getting it modeled to a graph, so can you directly like on P4 or or in SDN, like if you can have the switches and you can directly implement MIDAS there on the switches, and you can have that capability to kind of detect, okay, this packet was anomalous, or like basically we have to block this IP address because this flow was anomalous, something like that. And if you can directly do it at the network layer, so that'll be really interesting.
Yeah, I think for finding
a credible answer, thank you.
Yeah, I think for finding stuff like DNS tunneling, this technology wouldn't break a sweat, right?
No, not at all.
Yeah.
I mean, that's exactly the kind of anomalies you want to detect is stuff like that.
Right. Siddharth, is this an open source kind of concept? Like anyone can take this idea? You mentioned there were security vendors and other researchers. Like, is this a kind of open, free kind of thing?
Yeah. So the code is open source. Everything is open source, and it's an Apache 2.0 license. So anyone can feel free to like use it in their application however they want it. And at the same time, like it may require some customization if you want it to be like not for a network kind of data. So the results and the experiments and everything on the GitHub repository is on like NetFlow kind of data sets. But if you require it for a different setting, for a graph setting, then I'll have to like do some slight amount of work to improve it further and like port the application there. But everything is open source and it's free to use.
That's fantastic. When are you going to create your own company to monetize things like this? Because you've done some fantastic work and a great contribution.
Yeah, so like definitely like making a company requires a lot more effort. So I'm currently into research and I'm trying to like just extend this and like use different other properties of cybersecurity and intrusion detection space, and maybe like getting out some different things. So people did contact us like if we want to open a company, if they want to give an initial grant. But I think I'll just try and finish my PhD and then I'll just see if it's still not.
Good for you. Yeah. Good for you.
Yeah, starting companies while you're finishing your PhD is usually a challenging activity.
Yes, definitely finish. When is your PhD going to be finished?
So, like I finished 2 years, and I think it should take at least a year more. So, once it's like I'm on the finishing stages, I can just think of like whether we can still go ahead and use the IP of the research and like make a company. So people can definitely go ahead and they are deploying it in their systems, because I wasn't aware like how do we create a license and all those things I learned during my PhD. So people have like definitely implemented it in MIDAS, but like some researchers and some like my advisor told me the IP lies with the person itself. So we can definitely do it later if we want to.
Yeah.
So I'm just finishing and focusing on my research and trying to do it as soon as possible.
Yeah, never say you think you're going to finish in public, because then your advisors hear that and go, "Oh, you think that, do you?" It's like, wait till your next hearing. Yeah.
Doug, you sound like you've walked that walk, which you have.
No, not at all, Doug.
Siddharth, are people contributing back to your project?
So so like in fact, my original C++ implementation was also improved by another developer. So I am not a like very good software engineer kind of person or a good developer. So I just wrote the initial implementation. So someone like improved it further and like brought down the speed, like times taken to like even further like below. So it was around 0.3 seconds. So he brought it down to say 0.2 or 0.19, something like that. And so it's like it's quite nice to see people like they're contributing to the project, they're implementing it in different languages, and there are different ideas. So like based on that community discussion only, I'm getting further ideas how do we kind of extend it. And so these are not all my extensions which I talked about in this talk. So it's like having a network kind of layer, having a distributed version, and running it on non-graph settings. So these are all someone else is working on it, and I'm collaborating, or like I got an idea based on discussion, and then I'm extending MIDAS on those. So it's definitely like others' contributions as well, which I cannot neglect.
That's fantastic. Further questions for Siddharth? Siddharth, a great contribution. Thank you for coming on the show and talking about it. There is a link to Siddharth's GitHub. You can find it as soon as I fix the bug in my own code. I'm right there with you. I'm not the world's greatest developer either. You just kind of prototype stuff and make it work as best you can, right? But there is a GitHub repository that will work on getting in the show notes for this episode, where you can find Siddharth's work. Siddharth, again, thank you very much for your contribution to the community.
Thanks a lot.
And with that, we'll take a short break, come back with the security news. Stay tuned.